Intersections in Venn diagrams. Let's begin. Welcome to our tutorial on intersections in Venn diagrams. This slide serves as our introduction to the topic. Now, in mathematics, when we talk about the intersection of sets, what we're really looking for are the elements, the items that are shared by all the sets we're considering. Think of it like finding what's common between different groups. To help us visualize this, we use something called Venn diagrams. These diagrams are a fantastic way to represent these common elements graphically. You'll see how the overlapping parts of the circles in a Venn diagram directly show us the intersection. Over the course of this tutorial, I'll guide you step by step through understanding exactly what an intersection is, and more importantly, how to represent it using these Venn diagrams. We'll start with simple examples and gradually build up to more complex scenarios, including working with 3 sets. So, let's get started with learning about intersections. What is an intersection? So let's dive a little deeper into what an intersection actually is. As we discussed on the previous slide, intersections help us find what's common between sets, and now we're going to formalize that idea. The intersection of 2 or more sets, and listen carefully for this notation, is represented by this symbol. We call it the intersection symbol, and it looks like 2 overlapping curves. We use it to show where sets overlap. The intersection, in simple terms, contains only the elements that are present in all of the sets we're looking at. It's crucial to remember it has to be in every set. Let's look at an example to make this crystal clear. Suppose we have 2 sets. Let's call them A and B. Set A contains the numbers 1, 2, 3, 4, and 5. And set B contains the numbers 3, 4, 5, 6, and 7. Now, what elements do A and B have in common? If you look closely, you'll see that the numbers 3, 4, and 5 appear in both sets. Therefore, the intersection of A and B, which we write as an intersection B, using that symbol we just learned, is the set containing 3, 4, and 5. So, a intersection B equals the set containing 3, 4, and 5. Essentially, these are the elements that show up in both set A and set B. This is the core idea of intersection, and we'll see how this translates visually into Venn diagrams on the next slide. Make sure you understand this concept before we move on, as it's fundamental to everything else we'll be covering. Representing intersections in Venn diagrams. So now that we've defined what an intersection is, those elements shared between sets, and seen it represented with the intersection symbol, let's look at how we visually represent this using Venn diagrams. This slide explains the core visual principle. It states that the area where 2 or more of our circles overlap within a Venn diagram, that shared space, directly represents the intersection of those sets. Think of it like this. Everything inside that overlapping area is a member of all the sets the circles represent. We've already talked about how the intersection is denoted by a special symbol. We say it as an intersection B. If we're talking about the intersection of sets A and B, this overlapping region is the visual equivalent of writing out that an intersection B. The slide then simply indicates that we're going to walk through the steps of how to create this visual representation, and the following slides will do just that. We'll start with drawing the circles, then identifying the common elements, and finally shading the overlapping region to clearly show the intersection. So, get ready to see this concept come to life visually. Step 1. Draw the circles. First, we need to draw 2 or more circles that overlap. Think of each circle as representing one of our sets, like the sets A and B we talked about earlier. The key here is that they must overlap. Now, imagine you draw a rectangle around these circles. This rectangle represents what we call the universal set. The universal set is just a way of saying it includes everything we're considering in this particular problem. Everything inside the rectangle is relevant, but our circles highlight the specific sets we're focusing on. Finally, and this is crucial, the amount of overlap between the circles visually shows us how much potential there is for common elements. If the circles don't overlap at all, it means there are no elements shared between those sets. Their intersection would be empty. The bigger the overlap, the more elements the sets have in common. So now we're moving on to the practical side of things, actually drawing the Venn diagrams to show intersections. This is slide 4, and it's a really important step. In the next few slides, we'll actually identify those common elements and fill in that overlapping region. But this step, drawing the circles and the rectangle, sets the stage for everything else. It gives us a clear visual framework to work with. Step 2, identify common elements. So we've talked about what an intersection is, those elements shared between sets, and how we show it visually with overlapping regions in a Venn diagram. Now, let's move on to the second step in actually finding that intersection. This slide says, determine the elements that are present in all the sets you are considering. Now, this might sound obvious, but it's where students often make a little mistake. Remember, the intersection isn't about what's in most of the sets, it's about what's in all of them. Think of it like this. If you're trying to decide who can come to a party and you have a few requirements, they need to be on the guest list, they need to have RSVP'd, and they need to be able to bring a snack. Only the people who meet all 3 of those conditions can come. That's exactly what we're doing when we find the intersection. So, carefully look at each set and identify the items, the numbers, the letters, whatever the sets contain, that appear in every single one. We'll use these common elements in the next step to fill in the overlapping part of our Venn diagram. In the next slide, we'll actually shade that overlapping region, so it's important we get this step right first. We need to be absolutely sure we've identified everything that's common to all the sets before we move on. Step 3, shade or fill the overlapping region. The first bullet point says, shade or fill the overlapping region of the circles to represent the intersection. What this means is, once you've identified the elements that are common to all your sets, remember from the previous slides how we find those, you then visually mark that shared area on your Venn diagram. You can do this by shading it with a pencil, coloring it in, or filling it with a pattern. The key is to make that overlapping area stand out. And then, the second bullet point clarifies why we do this. The elements within this shaded region are the ones that belong to all the sets. This is crucial. That shaded area isn't just any part of the circles. It specifically represents the elements that are members of every single set you're considering. So let's move on to the next step in representing intersections using Venn diagrams. As we've discussed, the intersection of sets contains only the elements that are present in all of the sets. And we've already visualized how these sets are represented with overlapping circles. Think of it like this. If we were looking at sets A and B, the shaded area would contain only the things that are in both A and B. This is what we denote as a intersection B, which we read as a intersect B. This step is important because it prepares us for the next stage, where we'll actually write those common elements inside the shaded region, solidifying our understanding of what the intersection truly means. We'll see this in action with a couple of examples coming up, so you'll get a really clear picture of how this all works together. Example 1, intersection of 2 sets. Let's move on to our first example of finding the intersection using a Venn diagram. As we discussed in the previous slides, the intersection represents the elements that are common to all the sets involved. Here we have 2 sets, A and B dollar. Remember that capital A represents the set A, and capital B represents the set B. Set a dollar contains the elements red, blue, and green. And set B dollar contains the elements blue, yellow, and orange. Now let's follow the steps to find the intersection, which we denote with the intersection symbol. It looks like an upside-down capital, U, and we say it as a intersection B. Step 1, draw the circles. As the slide indicates, we begin by drawing 2 circles that overlap. This overlap is crucial as it represents the potential for common elements. We'll label one circle A and the other B, just like our sets. Step 2, identify common elements. Now, carefully look at both sets and identify which elements appear in both. If you examine set A dollar and set B dollar, you'll notice that the only element they share is blue. Step 3, shade the overlapping region. This is where the Venn diagram really comes to life. we shade the overlapping region of the two circles. This shaded area visually represents the intersection, the elements that are in both A and B dollar. And within that shaded region, we write blue because that's the only element present in both sets. So this diagram visually shows us that the intersection of set A and set B dollar, written as A intersection B dollar, is equal to the set containing only blue. We can write that as blue. This is a fundamental concept, and we'll build on it with more examples, including those with 3 sets, as you'll see in the following slides. Make sure you understand this example thoroughly before we move on, as it forms the basis for understanding more complex intersections. Example 2, intersection of 2 sets with numbers. Let's move on to another example, this time working with numbers. As you recall from the previous slides, we're still focusing on finding the intersection of sets and representing it visually with Venn diagrams. Now on this slide, we have 2 sets defined for us. The first set, labeled X, contains the numbers 2, 4, 6, 8, and 10. And the second set, labeled Y, contains the numbers 6, 8, 12, and 14. Let's work through the steps to find the intersection of these 2 sets. Step 1, as always, is to draw the circles. Imagine 2 circles overlapping each other. We'll label one circle X and the other Y. Remember, the overlapping area is where we'll find the elements that are in both sets. Step 2 is to identify the common elements. So, looking at both set X and set Y, what numbers do they both have? If you examine them carefully, you'll see that the numbers 6 and 8 appear in both sets. Those are our common elements. Finally, step 3, we shade the overlapping region of our Venn diagram. This shaded area represents the intersection, the elements that belong to both X and Y, and within that shaded region, we write the numbers 6 and 8. So visually, this diagram shows that the intersection of set X and set Y, which we write as X intersection Y, is equal to the set containing 6 and 8. We would write that mathematically as the set containing 6 and 8, using curly braces. Remember, the intersection is all about finding what's shared between the sets. And this Venn diagram gives us a clear picture of that shared space. In the next slide, we'll extend this concept to 3 sets, so make sure you've got a good grasp of this before we move on. Intersection of 3 sets. As we've seen with 2 sets, finding the intersection involves identifying elements present in both sets and representing that shared space in the overlapping region of the Venn diagram. Now, the good news is, this concept isn't limited to just 2 sets. The first point here tells us that the idea of an intersection extends to working with 3, or even more, sets simultaneously. So, instead of just looking for what's common between 2 groups, we can find what's common across multiple groups. And this brings us to the second point. When we have 3 sets, the intersection, meaning the elements present in all 3, is represented by the region where all 3 circles in the Venn diagram overlap. Think of it like this. If each circle represents a set, the very center where all circles intersect is the only space that contains elements belonging to all 3 sets. We'll see this in action on the next slide with a concrete example, but it's important to visualize that the intersection becomes that central, shared area when dealing with 3 sets. Remember, we're always looking for what's common to all the sets involved. Example 3, intersection of 3 sets. Let's move on to a slightly more complex example. This slide, titled Example 3, Intersection of 3 Sets, will show you how to find the intersection when we have 3 sets instead of just 2. First, we have our 3 sets defined here. Set P contains the numbers 1, 2, 3, 4, and 5. Set Q contains 3, 4, 5, 6, and 7. And finally, set R contains 4, 5, 6, 7, and 8. Now, let's work through the steps to find the intersection of all 3 sets. That is, the elements present in all of them. Step 1 is to draw the circles. Imagine 3 circles overlapping each other. This is crucial because the overlapping area will represent the intersection. We'll label these circles P, Q, and R, corresponding to our sets. Next, step 2 asks us to identify the common elements. We need to carefully look at all three sets and find the numbers that appear in every single one. If you examine P, Q, and R, you'll notice that the only numbers present in all three are 4 and 5. Finally, step 3 is to shade the overlapping region. Remember, for three sets, the intersection is the area where all three circles overlap. So, we shade that central, overlapping region and write the numbers 4 and 5 inside it. This visually represents that the intersection of sets P, Q, and R, which we write as P intersection Q intersection R, is equal to the set containing 4 and 5. So, P intersection Q intersection R equals the set containing 4 and 5. This example reinforces that the intersection represents the elements shared by all the sets involved, and in a Venn diagram, it's shown by the area where all the circles overlap. Keep this in mind as we move forward, because understanding intersections is fundamental to many other concepts in set theory. Key takeaways. First, remember that the intersection of sets, and that's finding the elements that are shared between all the sets, contains only those elements that are common to all the sets involved. So, if you're looking at sets A, B, and C, the intersection will only include things that are in A and B and C. Next, in a Venn diagram, we visually represent this intersection. The overlapping region or regions of the circles always represent the intersection of those sets. Think of it as where the sets come together. Finally, and this builds on what we saw with three sets in the previous example, for multiple sets, meaning more than two, the intersection is specifically the region where all of the circles overlap. It's that very central area where everything is shared. Let's recap what we've learned about intersections in Venn diagrams. This slide, titled Key Takeaways, summarizes the most important points. Now that we've solidified these key takeaways, let's quickly look at some common mistakes students make when working with intersections, which is covered on the next slide. Being aware of these will help you avoid those pitfalls and confidently solve intersection problems. Common mistakes. First, it says incorrectly identifying common elements. Now, remember from our earlier examples, the intersection, and we've been representing it with that upside-down capital U symbol, means we're looking for what's shared between all the sets. A very common mistake is to include an element just because it's in most of the sets, but not all of them. So, always double-check that any element you include in the intersection is actually present in every single set you're considering. Take your time with this step. It's the foundation for getting the right answer. Next, we have shading the wrong region. Remember, the overlapping areas in our Venn diagrams are key. When you're shading to represent the intersection, you only want to shade the parts where all the circles overlap. It's tempting to shade larger areas, especially if you're dealing with just two sets, but resist that urge. Only shade the region that represents elements belonging to all the sets involved. Finally, and this is a big one, confusing intersection with union. These two concepts are often mixed up. We've talked about intersection being about finding what's common to all sets. Union, on the other hand, is about combining all the elements from all the sets, regardless of whether they're shared or not. So, if you're asked to find the union, you'd include everything in at least one of the sets. Think of it like this. Intersection is an and situation, elements must be in all sets. Union is an or situation, elements can be in any of the sets. Let's move on to the final slide, which highlights some common mistakes students make when working with intersections in Venn diagrams. This is really important, so pay close attention. So, keep these 3 points in mind as you practice, and you'll be well on your way to mastering intersections in Venn diagrams. Are there any questions about these common mistakes before we wrap up?